All right, so back to our home page, we're jumping into lesson 3.3. And I'm going to replace this video here. So if you already watched it, it's no big deal. The only difference is toward the end of the video. This talks about population changes in different states. That was the share your work that I did last quarter. I have a new one. So I will be replacing this video, but most of the video is totally relevant to what we're doing. 99% of it, really.
But you'll
Okay.
replace it like soon. I mean, we could watch it soon.
Yeah, so the video I was trying to upload in the beginning of class was part of the replacement for that video.
Okay, thank you.
And the rest of the replacement is what we're doing right now. So we're going to get 2 new videos there today. And they'll also be in the playlist. So the main objectives here, I've kind of already talked about. We're going to be taking these situations and trying to write them down as equations. We're going to try and write them down as tables, and we're going to try and make some graphs out of them. We're going to decide when linear models are appropriate. And a linear model is when I have that constant rate of change, okay? And again, some examples of constant rates of change are, I bike at about the same speed unless I hit a big uphill or a big downhill. So if it's flat, I'm just kind of cruising along at a constant speed. The blood alcohol examples, if someone has a few drinks, then stop drinking, then their BAC is going to start dropping over time. So that's the first graph. If they keep having more drinks, then their BAC is going to rise for any particular time. And that's another example that we could say, yeah, it's lining up pretty much. Does everything in the world line up? The answer is absolutely not. There's tons of things that don't, but we often have things that do. Or we sometimes kind of approximate them with lines just to make life a little easier, to make stuff happen. So I'd recommend reading through this page a little more carefully later. I'm going to skip over it right now. This is a similar example to what I just went over. They have a slightly different person here. They have a 150-pound male that had 3 drinks, and we can see their BAC dropping. So this is similar to the example I went over yesterday and talked more about at the beginning of this class. So some things we can do here when we're talking about these things that change over time, we can have equations that describe the change. We can have tables that show the change. We can have graphs like this one here that show the change, and we can also describe in writing that change. And you'll know in the first part of class today, I attempted to describe how, if that woman kept drinking more drinks, how her BAC was going to change. And so that's that verbal thing there. So we're going to try and get better at writing in words what's happening. Again, I was trying to show in the earlier graphs that this idea of slope, which we also call rate of change, on a graph is moving from one point to another, kind of like along a city block. So I can go up and right to get to a new point. And if things line up, if you take the up value divided or sometimes the down value, if you take the vertical value and divide by the horizontal value, you always get the same answer. Like 2 over 4 is 0.5. 1 over 2 is also 0.5. So it always works out to be the same value. And so we'll look at some more of that too. Okay. The first couple of examples here, I'm gonna just do them with you, and then I'll get you set up for the next part, and we'll split up into groups and do the next parts. So here we want to be able to be given information about the rate of change or slope and the starting value and turn it into an equation. So let's blow this up a little more. And you guys have this, I think you have the same problem I do. Does anybody have their lesson 3.3 up in front of them?
It out, and mine says write the equation of a line with slope 3.
Okay, so you have a slightly different number for question 1. Okay.
But it does have the 0.6.
Okay, yeah, so it's similar but different. And the bottom line is when we write an equation for a line, the 2 things we need to know. So this is again for an equation of a line. There's many ways to write one, but I think the best one, and this is what our class uses, is something that looks like this: y equals mx plus b. And this value here, m, that's what we call the slope. It's also known as the rate of change. So AKA rate of change. The value for b over here, that's sometimes called the y-intercept, because it's the point where our line hits the y-axis. And it's also known as the initial or starting value. So in the situation I got for number one, they just told me, hey, your slope is, mine was I think 2. And they said my y-intercept is, and they gave me the 0.06. And so the slope is pretty straightforward. They're saying, hey, that's your m right there. That 2, that's your m. As far as the point goes, a point is always an x value followed by a y value. And the y value is the value of b. So this point right here tells me that b is 6. So when I write down my equation for this situation for my number one, I would write y equals 2 times x plus 6.
So I would write y equals 3 x plus 6.
That's correct.
Okay, thank you.
So just a little more about this particular equation here. Let's go to a new page. So y equals 2x plus 6. If I decided to let the x value equal 0, then I would get y equals 2 times 0 plus 6. Well, 2 times 0 is 0, and 0 plus 6 is 6, right? And that's that point I had. I had the point 0.6 to start with. So this is just, I'm just verifying that, yeah, I have the point 0.6, and 6 is that value for b. The other thing to note here is whatever number is being multiplied by x, that's what we call the slope. So sometimes we use the letter m for that. So my slope is just 2, but often we write slope as rise over run. So if the number you have isn't a fraction, the easy way to make it a fraction is just divide by 1. So I could also say the slope is 2 over 1. And because the 2 is positive, what that means is from any point, go up 2. And since 1 is positive, that would be right 1. Negative numbers have a slightly different meaning. So let's look at negative number, for example. So suppose I said my slope was negative 2 over negative 1. So remember, the numerator is what we call, oh, I can't spell, rise. And the denominator is what we call run. And in this case, a negative 2 would mean to go down 2. The negative is a down. And the negative for the run would mean go left 1, is how I would interpret that. So if I had a particular point on the graph right here, this slope would say to drop down 1, 2, and then go right 1, or left 1, sorry. And that would put me right here. So in this direction, I went down 2, and then I went this direction for left 1. All right, let's get back to our activity here. Yeah, so for me, I'm just going to type in my y equals 2x plus 6 and move along. All right, so Terry is skiing down a steep hill. Terry's elevation, E, in feet after t seconds is given by the equation E equals 3,400 minus 60t. So I just want to pick apart that equation, then we'll try and fill in the blanks here. So mine's 3,400 minus 60t.
Which even if mine's 3,700 minus 40t, I can still like learn from what you're doing.
Exactly.
Okay.
All right, so that's the equation they gave me. And in my head, I'm thinking, okay, the equation we started with was like a y equals mx plus b. So I want to kind of make it look a little more like y equals mx plus b. So it looks to me like, you know, the y and the e are probably the same thing. Okay, they match pretty good. On the other side of my equation here, I have a t. So that's probably like the x. So the 60 here must be like my m. And then I guess this number by itself right here is b, because b is supposed to just be a number by itself. So I'm just going to switch the order of these right here underneath. I'm going to leave, oops, I'm going to leave the e out front. That's good. But I'm going to take the 60t and write it first. Now here's a catch. That negative is really attached to the 60. So when I rewrite it, it's got to be negative 60t plus 3,400. And again, that 3,400 is definitely a positive number. And hang on, my computer's complaining it's about to shut off because I neglected to plug it in. Downside of laptops, you got mobility, but power issues happen. 1 sec here. Okay, we got power. So I didn't have to rewrite it. I just chose to because I like the variable thing to go first and the plain number to go second. But what this is telling me is that the slope, m, is negative 60. B is the 3,400. Okay, so let's see. B, that must be the starting value. That's what we call that. What am I starting here? Okay, well, it says E equals, and so the starting value here must be the starting elevation. So it looks like my version of Terry started at 3,400 feet. Okay. So the y-intercept's usually pretty straightforward to interpret. The slope's a little trickier. So the slope, I have to remember, I'm trying to think about rise over run for slope. So I have to write this as a fraction. So I'm going to write it as negative 60 over 1. So then the question is, well, what does the 60 mean and what does the 1 mean? And the way it always works is the top number is the change in what you're calculating, and I'm calculating elevation. So this top number here is my change in elevation. And so the bottom number must be the change in my other variable, which is time. And I think this was hours. Let's see. Oh, seconds. Right. So read the fine print. So my bottom number is a change in seconds. And I'm 90% sure the change in elevation is feet. Miles, I don't think makes sense for the number 3,400.
It's feet.
Feet, yep, right there, feet. So elevation, feet. So this negative 60 is really feet per second. So anytime I analyze a situation like this, whether I'm given an equation or not, I got to think hard about what the slope means. What's the numerator mean? What's the denominator mean? And the numerator is always what you're calculating. Sometimes we call that the independent variable. Sorry, the dependent variable. I lied. Dependent and the bottom number is the independent variable.
So the minus 60 is the dependent?
That's correct, because
Okay.
that's the elevation. Because the elevation depends on what time we check out what Terry's doing.
Okay.
So generally, if time is involved, time has to be independent because we have no control over time. It just keeps on moving.
All right.
All right, so I think we have enough information to answer that question. And you have to modify for your numbers. Okay, so the equation tells us that Terry started skiing. Let's see, it could be a time or elevation, I'm not sure yet. The equation tells us Terry started skiing at a time or elevation blank, and his blank is blank by blank. Ooh, okay, let's see if we can piece this together. So it's either a time or an elevation here. And then this one, feet, seconds, second each foot or feet each second. All right, so let's see what's down here. Time or elevation, increasing or decreasing. Okay, so once I see the increasing or decreasing, I go like, okay, so that is slope. Okay, is Terry going up or down?
Down.
Down, okay, so I got decreasing there. So I know the second part here is about the slope now based on that cue. So I can go back up here, and this first part must be about the y-intercept. Y-intercept is an elevation. So the equation tells us Terry started skiing at an elevation of, for me, it's 3,400. Double check what yours is. And that was feet. And his elevation is decreasing by 60 watts. Anybody?
60.
Each second.
Feet each second. Excellent. You got it. Yeah, it's feet per second is what we talked about earlier. And sometimes people say it feet each second, feet per second. Those are two ways to say the same thing. And for me, it wasn't obvious what they wanted for the sentence here until I kind of went through all of the different parts, and the increasing or decreasing got it for me. It's slope that increases and decreases whatever the dependent variable is, which is elevation here. That was a tough one.
So
All right.
mine would just be like, in place of 60, it would be the 40.
If that's your slope, yes.
Yes. Because it's 3,700 minus 40t.
Yeah, so the number times t has to be the slope.
Okay, thank you.
All right, let's take a look at the next page. So the next page is just a little more playing around with the general idea of slope. So I'm going to leave you guys to play with that one on your own later, and I'm going to skip on to a more interesting question here. So we've got a sports team is planning a fundraiser. And so, by the way, I skipped a couple of pages here. I am now on the fundraiser page in this assignment. Problem situation 1. So the sports team's planning a fundraiser to help pay for equipment. Their plan is to sell T-shirts to friends and family and hope to raise $500. The local print screening shop will charge them $75 to get things set up and then $5 per shirt. And they plan to sell the shirts for $15. So I just want to talk about how the setup's going to work on this. And then I'm going to set you guys into groups to try and answer these questions. So, notebook. So I'm just going to write a summary of that. So you may want to reread that on your own. So my summary there is 1, we're trying to raise, or they're trying to raise $500. Another thing is to set up the T-shirts, there's a fee for that, and that's $75. So it doesn't matter how many T-shirts they print, they got to pay $75 up front, right? So this is, again, I think that's an initial value. They got to pay that before the guy's going to start printing any t-shirts. And then there's a per t-shirt fee. Of $5. So these right here are their costs. And then they're going to sell the shirts at $15 per shirt. Does that sound like an accurate summary of that paragraph there?
Yes,
Okay,
exactly.
so I'm going to go read it again. So usually when I'm solving a new problem like this, I got to read it several times. I got to take notes. I got to read it again. Am I really looking at this right? Okay, so we're doing a fundraiser. We're selling t-shirts and we want to raise 500. Okay, I got a note of that. The local screen printing shop will charge $75 setup fee. Okay, so before they're going to print anything, they're going to say, hey, give me 75 bucks. Okay. Then every shirt I get printed from them is $5 a shirt. Okay, cool. So I got the cost and then I got the money they're going to make. And the difference in those two is going to be their profit. So profit is always the sales minus the cost. Sometimes we say it's revenue minus cost. So this right here for sales, sometimes the sales money is called revenue. And what we want to know ultimately is what's the profit? And profit is always those sales, that revenue minus the cost. All right, so I'm going to write that down in a couple of different ways, and I'm going to set you guys loose to try and answer some questions. So let's see, again, we're trying to find profit. And the sales that's that $15 per shirt. So anytime I have that per thing, that's got to be the slope. So did they give me a variable? I'm just going to use X for now. So 15X, that right there is my my sales, right? My revenue. Then I have to subtract the cost. Well, okay, there's a $75 cost, so I got to subtract that. And then I have to subtract $5 per shirt. And because of the per is involved, that means it is also a slope. So it has to be multiplied by X. So these two here are my costs. So this is what I could call the fixed cost. And this one's the variable cost. Now, hopefully in a previous math class, you learned about cleaning up things like this. And I have what are called like terms here. So because the 15X has an X in it and the 5X has an X in it, those can go together. So 15X's take away 5X's leaves me how many X's?
10.
10 X's, yeah. So I can rewrite this profit. I'm just going to write P for profit is equal to 10X minus 75. Right, and if I were to start making a table based on that, for X is the number of shirts and Y is the profit, if they don't sell any shirts, they spent 75 bucks, so they're in the hole $75. If they only sell one shirt, right, they made 10 bucks to balance the 75 they lost. I think that puts them at negative $65 overall, right? They're still 65 in the hole. If they sell two shirts, that's another 10 bucks, that positive. So that's going to put them at negative 55 in the hole. So they're going to have to sell a certain amount of shirts before they finally make some money. Because right now, if they only sell 2, 3, 4 shirts, they're in the hole for a while. And I can kind of guess, right? Like if they sold 8 shirts, 8 times 10 is 80. They made 80 bucks, they spent 75. So what's that? They finally make a profit of $5. So if we jump down on the table to 8 shirts, 8 times 10 is 80 minus 75. They finally made $5 profit. So these are all losses here. And finally, I have a real profit. Right, and ultimately, how much money do they want to make?
500?
500, right. So we got to get to that. All right, so here's what we're going to do next. So I got the setup going for you. We got to build a table here, and they only put in 1, 2, and 10. To answer some other questions, you may want to make some other calculations. So we got a table to fill out. How much additional profit does the team make for each shirt they sell? And I kind of answered that question on the other page, but not directly. Create a linear model. Definitely did that in the notes just now. Can we graph it? And remember, to use the graphing tool in this system, you only pick 2 points to plot, and you decide which 2 points they are. Okay, so your group will have to decide that. How much money can they raise if they sell 30 shirts? That's not too bad. How many shirts do they need to sell to have reach their goal of 500? That's a little trickier. So we're going to split up into groups right now and make sure we can all agree on those answers in your group. I'm going to stop sharing for a second so I can get the group set up. Let's do 2 or 3. I guess we're going to have to use 2 rooms. All right, so let's do this there. Okay, so I'm going to open up the breakout room. So please jump into your room and start trying to answer those questions with your group mates. If somebody already has an answer, make sure you can agree on it. That way everyone gets a better score. And then call me over if you have a question.
Thank you.